Hello everyone and welcome to another episode of Interstigation. In today's episode of Interstigation, we'll go over 2023 AMC 10B number 14. This question asked, how many ordered pairs of integers mn satisfy the equation m squared plus mn plus n squared is equal to m squared n squared? If you don't know, we are solving a Diophantine equation. Basically, that means we're just solving for the integers of an equation. And two common methods we might use to solve these two Diophantine equations are factoring. So if you think about, say, Simon's favorite factoring trick, that is if you have x plus 1 times y plus 1 equals xy plus x plus y plus 1. So something along those lines, there are a lot of factoring methods in one variable. You could extend that to two variables, or a more, I guess, primitive method, completing the square. So completing the square is another way for us to find the integer solutions. For example, if we have, say, x squared equals 4, then obviously x is equal to plus or minus 2. Or there is a third way in this question specifically. If you look at the right-hand side is a fourth degree polynomial. So this fourth degree intuitively would grow much, much faster than the left-hand side, which is a second degree polynomial. So if you think about when mn gets really large, when m and n approaches infinity, we would have the right-hand side much, much larger than the left-hand side. In that case, they cannot be equal, obviously. So the third method is to bound. So by bounding, you can see you can kind of restrict m and n to be quite small numbers and kind of restrict the domain of m and n that you have to test out to see what the equations are. But for time's sake, we are just going to do one of them, and after working through it, I think number 2 works the best for this question. So I will introduce the method for completing the square, but I highly recommend you to pause the video and try all three methods, see if you can get the same answer. Then you know the answer is definitely correct. And if you're interested in learning about the other two methods, feel free to leave a comment down in the comment section below, and I might make a video out of it. But anyway, let's get started on the second question. Pause the video if you want to, and let's go on. All right, so on the left-hand side, it is almost a perfect square, but to get to a perfect square, we just need 2 mn instead of 1 mn, so we have to subtract an mn on the other side. On the left-hand side, and this becomes a perfect square. We can move the mn to the other side and see this is mn squared plus mn, and you can see that here the right-hand side looks very much like a square as well, so we might as well complete the square of that. So mn squared plus mn plus 1/4 minus 1/4. That brings us to complete the square on the left 3 terms. So that becomes mn plus 1/2 squared minus 1/4, which that gives us m plus n squared. All right, and in this case, we can multiply by 4 on both sides of the equation, just so that we are dealing with just integers, because we want to utilize some properties with integers. We can multiply the 4 inside the square, that becomes a 2, so that becomes 2mn plus 1 squared minus 1. Now if you examine this equation over here, then you can see that it is basically saying there are 2 square numbers whose difference is 1. You think about all the square numbers, 0, 1, 4, 9, 16. As the square numbers get larger, they also get further apart. Therefore, these two must be quite close to each other. And in fact, if you think about it, the only square numbers that could work is 0 and 1. And therefore, we can conclude that either 2 times m plus n is equal to 0, which that leads us to m plus n is equal to 0, and we need to have 2mn plus 1. This is, note, plus or minus 1, because minus 1 could also work in this situation. Negative 1 squared is still 1, and 1 minus 1 is 0, of course. So this gives us two different possibilities. We could have mn is equal to, if it is plus 1, mn is equal to 0. If it is minus 1, then moving that to the other side, mn would be solved to negative 1. So m and n are basically just opposite numbers. And from now, you could basically just test out numbers and you could probably find the solutions pretty easily. But otherwise, if you want to solve it rigorously, you can say, okay, n is equal to negative m. So if we plug this in, we get m times negative m is equal to 0. So m is equal to 0. M squared is equal to 0. So m is equal to 0. That means n is equal to 0. This is a valid pair. And if we have mn is equal to negative 1, then m times negative m is equal to negative 1. So m squared is equal to 1. This gives us two pairs of solutions. That is m is equal to 1. In this case, n is equal to negative 1. Or m is equal to negative 1. And in this case, n is equal to positive 1. You can see that these two pairs are symmetrical because in the original equation, the expression is also symmetrical with respect to m and n. So we would, if m comma n is a solution, then n comma m is also a solution. But as you can see, these three are the only solutions of this equation, and thus we choose answer choice C for this problem. And that is it for number 14. And I'll catch you in the next video. If you have any questions you don't understand, feel free to leave those in the comment section and I will answer all of the questions. And if you have any other questions, feel free to leave those in the comment section as well. And I might help you through a comment or a video. But regardless, I will see you hopefully in the next video, and farewell for now.